I hope we are live. I'll quickly check if we are live or not, and then I'll start the live stream. I guess it takes some time to appear in the channel page. I hope I'll quickly check if we're. So yeah, we are good. And now I'll be taking you to the problem solving screen. And here you go. This is the today's problem. And for this problem, I won't be using my iPad. Rather, I'll use this sticky notes to write the important things out of it. Or basically I can do something like this. Sorry. Okay, we have to change the size from the sidebar. Let me check. This is the app size. Okay, so it's already big, so I don't think we got more options over here. Let me just copy this problem statement and let's see what we can do out of this. Okay, everything is fine. Come here, paste it. Okay, so that's weird. Let's read the problem here. Okay, or I can do one thing. Let me just take this particular thing out like this, and expand it up, change the layout to something like this, and here I'll change it to further something like this, and better to open a notes app over here. Correct. Yeah, so I think we got it covered. So I'll be writing the logic over here, and I can do something like this. Maybe this is good. Correct. Yeah, fine. So now let's read the problem and build the logic out of it. So minimum recolors to get k consecutive black blocks. Minimum recolors to get k consecutive black blocks. Okay, you're given a zero indexed string blocks. So we have been given blocks, which is a 0 1 string, correct? And it has a length of n, these are the dimensions, where block I is either, so it is a zero index string. That doesn't mean it's 0 1 string, it's a binary string. That is not there in the problem statement. So it is actually a string which contains w's or b's. Okay, so block the ith index will represent color of the ith block. Yeah, so whatever character that is there at the ith index, it will represent the color of the ith block. The characters W and B denote the colors black, white and black respectively. Correct? You're also given an integer k. So this is just the information which we need. Then we are given for blocks. Then we have k, which is the desired number, okay? Desired consecutive black blocks. Cool. In one operation, you can recolor a white block such that it becomes a black block. So operations are defined as follows. So in one operation, you can recolor white to black so that it becomes a black block. Correct? Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. So they basically mean to say that what is the minimum number of white blocks which we need to convert it to black in order to get k, at least one occurrence of k consecutive black blocks. So for example, we have this test case over here. If I copy this and I paste it over here, wow, this is really good. Okay, let's use some cool font. Something like mono text will work well, and I feel this typewriter gives that kind of feel. Montserrat is also cool, but I don't like it. I think I'll go with typewriter. Cool. So yeah, we have this example over here, and we have k given as 7. So we want 7 consecutive blacks. Currently we have, if we check the maximum number of blacks which we got is 1 2 that are consecutive is 1 2 1 2. It's 2 only. So what we see over here, that if we combine these two folks, it will need 3, basically it will need 3 whites to turn them to black in order to make 7 sized consecutive black blocks, right? So in that case we have to really build a strategy by which we can try to optimize the solution. Okay, so let's talk about the brute force solution. Now we understand the problem here. In this case, what they did was to take this string only and convert all the whites that are there in this particular section to black. Correct? So k is 7, which is given to us. Nice. So if I think about brute force solution, which will require to consider all possible cases. So here I'll do one thing. I'll make combinations of whites. Like I'll turn some whites to black, some whites to, like, keep them white only. And doing this, we will make combinations wherever the positions of W is there in the string. So like, let's say there are X W's. So then there will be 2 to the power X possibilities, right? Because each W we have two, for each W we have two options. First option is to convert that to black. Second option is to keep it white, right? So these two options which we got, right? And then we have to think about next things, which is basically in doing that, we'll be able to, the next step will be to, for each configuration we need to find what is the maximum consecutive black size, right? And the configuration in which we have least number of whites converted to black is the ideal answer. But this could go really wild because there are 2 to the power x such configurations, and checking the next thing, the step 2, is also time consuming. So in that case it will go up to somewhat like 2 to the power x multiplied with n. In worst case x could be n as well. So we got n as 100, which is 2 to the power 100, is something like 2 to the power 10 to the power 10, which is 10 to the power 30, multiplied with 10 to the power, multiplied with n, so it will be 32, which is obviously a bad time complexity and it won't be accepted at the moment. So we need to think of some good approach, which is better approach and better optimization than this. Okay, so what we can do is basically this looks good. So what we can ideally do here is this. So we have this thing here, we have this information that the contiguous pairs, we can count them, right? So we can say that there is there is two black, and we can count the number of whites in this region, right? And if we know that there are two, and we need to convert two more to get six, right? Then it will make our steps easier. It will make our approach easier, correct? So it's like 2, 2, and WWs are zeros and zeros. So we need to be aware of two things here. First is the current contiguous window, which is the size of the window, and next is the space between it. That also matters, because let's say we have W and BB, and let's say there are a lot of whites, and then we have something like this. So in case if you want to get 5 or let's say 6 blacks, we won't be taking this entire section and converting that to something like all blacks, right? What we can instead we can do there is basically pick this up and convert it to black 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 and black black black. It will make it 6, and we just need 3 conversions. Make sense? So what we need to think here, what if we are traversing in this particular order, what is the information we need? So if we are here, we should know that these many whites are there at the next level, right? And if we come here, we know that sorry, we know that there are 4 W's at the end. So doing that, we can have an estimate uh, of something like, this is 3 4 7. We can have estimate of what is next, and so let's say if we have something like a prefix sum, which at each position defines how many whites are there before that location, right? So if we are at here, we know that there are these many whites and 2 blacks on the way, right? So don't think this is getting, I don't think this is having any lead in my mind to reach the answer. What I instead think, like there will be definitely some part of the string which is the answer. Correct, probably this one. So what is unique in that? So for this particular value to be part of that answer string, if it is a white one, it will be, yeah, it will be definitely taking all the whites which are there before it. Like if it is this W, it will be definitely possible that it is a part of something like this or something like this. Basically it will have some B's at the end, and which makes the thing. Okay, let me think about it. How can I do this? If we take a look at this example, k is 2 over here, what they did was they just picked this part of string. Right, makes sense. So how we can do it in one go? So for doing it in one go, like one pass, we need some information. Like if we are at this location, we should know that what is the condition afterwards. Like that we can know with some sort of logic. Like we can have the count of whites which are next to it, count of B's which are next to it. But that will only help to get us an idea about uh, whether we can form or that's what we need, man. Let me think this way. If I'm going in this direction, in the in left to right direction, here if I'm at this particular level, this particular index, what should I ideally do? I should know like how many W's are there in the next part, right? If I know there are 10 W's, for example, and 3 B's, what I can do is if the answer string contains this particular element as its first element, basically if that starts from here, we would try to find out the minimum possible thing which takes to which is required to create this thing. From this point we try to find the minimum length. Yeah, I think it's easy. So if I tell you about the n square approach which just popped into my mind, is that for each particular index we think that let's imagine if it is going to construct the answer string which is ideal, which has least number of conversions, least number of operations. In that case, this W has to be there in the string, and we will start our making that string from this point. So this is a unique kind of exploration where we try to hit the number k by taking few or more elements in the forward direction. Then we come to this particular part, right? Then we come to this particular part, and doing that we also keep track of how many conversions we did at the each case, at the each spot, and at the end we'll be able to crack the logic. Makes sense? So I'll show you how what I'm meant to say. Correct. So let me just tell you how to solve this. So first of all we need to do, so this is a n square approach. So imagine each We'll be going for in a for loop, which is I equals to 0 to I equals to n, right? And what we are going to do here is this. Consider that the ideal string start from I and do the necessary conversions right direction until we get a contiguous blacks. Okay, so here we go. Let me do this. How to move ahead with this? This should really take very less time. So I need to maintain I and j's, and we need to have an answer, which is currently the max one. Is it? If it is int max only, if it is not minimize, in that case we will be no, that is not possible. There will be definitely a case which will minimize it. So we return answer at the end. And here what we will be doing is we will be creating a for loop which goes in the box size, and what we do next is we have a variable which is the count, which is initially 0. Then we go to for integer j equals to I. Yeah, we'll include that index, and j is less than size. However, we can break it whenever we reach the count. If cnt is equal to k, then basically you have hit the uh, so basically the cnt is for the number of conversions you did. Okay, so here we should check whether the length of the this is also a mistake, whether the length of the current window is k. If it is k at the moment, but this will be checked at the end. If it is k, it means that taking this element, it makes it k. So what is this? J minus I is equal to k. Then we have to do this. We have to update this answer equals to max of answer comma count. Break it from here as well. And then we have to do the operations which are there. So if it is a black one, which is like if blocks of j is equal to black, in that case we have to do this. We have to increase, we have to do nothing. We have to just do something with, if it is a y, then we have to do a cnp plus plus. So it will increase the count that we have made one conversion at the moment. This will count the number of conversions we made till the point when the window size is k, at least k, right? And when we spotted a black, it is already keeping a count of the black ones in the terms of this difference. So I think this is the case, and we are good to go with this. And we are breaking here so that we can just avoid the further calculations and hiccups. I think this is the solution. Let's test it up. Can I fix the layout? Right, run it and save it. So this is giving me some wrong answer. This is some kind of weird answer, to be honest. This should be min, correct? And I think I'll get an answer for sure, and it will be accepted for sure. But this is still n square solution. Now I can think of something which is order n, and here we got some problem. 336. It was possible to convert this, and we could have got reported 3 conversions. What happened wrong here? So j started from 0. It went all the way up to n minus 1. N minus 1 minus 0 is actually n minus 1. So this is a very simple mistake because it is 0 index, right? This beats 100% of the complexity means probably there is no order n solution, but I'll check the editorial. No man, can you think of some easy solution for this? The answer is even if I calculate the prefix sums, if I keep track of what's next, I always need to remember what position, what is the distribution of the particular given distribution of indices among colors which we have. Right, so if I check the solutions here or submissions, editorials, let's check it. So this is your order n square approach probably. Oh, this is order n. And then we have the sliding window which is order n only. Okay, so we need to think better because I'm not satisfied with order n square at the moment. I am not seeing the editorial. I'll just rethink again. If I go with something like sliding window, then I have to keep track of how many whites we have, and the moment we get a black, we can dump this particular white. Right, like we start from here, we keep going, we keep going, and the moment we got a black, we can dump 1W. Yeah, so there exists a good solution, better solution, but I'm not really interested in that because it is a live session, and here I'll be talking only about the solution which passes the constraints. I'll think about it in my offline time, but currently I don't want to extend this a bit because you already see the time. Okay, so this is it for today, guys. I hope you enjoyed this, and that is it for today's session. Let's meet tomorrow for the next challenge. Okay, till then, goodbye. Take